I'm going to talk to you about distributed storage in the cloud. But you probably see that already. Will hear me well. And in this presentation, I will have a high-level overview of the storage options. Now, I by no means want to be claimed that I'm expert in all of them. And in this case, because this is a hybrid presentation, we have a fantastic opportunity. If you want to say, hey, Peter, you are wrong, that's complete bullshit, then please do so, and I will learn something new. So when we talk about the storage, I was thinking about that if you are really thinking about the storage from very high level, we can think about our applications those days either being stateless, right? You probably, many of you heard this word, or having a need to store a state somewhere, right? And that somewhere is what I will refer as storage, right? So in this case, we are going to talk about the storage in a very general term, ranging from a very simple storage as a file system and all the way to a databases which can offer a very complicated API for to do that. Now, when we talk about the storage such as a file system storage and so on, it's kind of relatively simple and then understood, but the category of the database itself is very broad and complicated, right? You can think about the databases designed based on data model, the query language we use, really the purpose we build out, and really even internal design considerations, right? How it's internally designed, right? So I have to go more in this technology. If you look at the databases from their model standpoint, the most common databases you may hear out there would fall into one of those items here. And it is not really exclusive, right? There are a lot of very niche databases which can offer very specific data model as well, besides those. What I think is also very interesting, what has been going on with databases recently, is what we also have databases which are called multimodal databases, right? That means you can take the same database and use that with multiple types or even different data model types, right? Or you can even talk through that technology with multiple protocols, right, on a wire. So, for example, you will find many relational databases embracing some JSON support, so they can use as a sort of document database of sort as well. Some of them, for example, MySQL, even has an additional language in a wire protocol it supports through their doc store interface. Then you can have the API protocol, right, which is much more similar to their to your document-based database compared to relational database. Now, there are a whole bunch of other things you can consider about the databases. One thing I think is interesting, if a database is focuses on their transactional workloads, or is it analytical, or maybe as some of the new databases do that, that is both. Are you looking to look at that database or data store as their persistent and primary data store, or is that used as a secondary data store, some sort of cache which you don't really, well, care that much about, right? And that can be regenerated if needed. We also have right now databases which come from a standpoint of either being in memory or using a disk storage. Some databases are now built to be really natively distributed. Think about CockroachDB folks who are here, or Yugabyte, where technologies such as MySQL or Postgres, they are really built as a single node database at its core, right? So you can see a lot of variety out there. And another thing, interesting innovation, which goes those days, which I should mention, is the blockchain databases, right, which come with its own unique values for some particular applications. So my talk is titled with a distributed keyword. Now, well, distributed, that is a wonderful keyword, because if you put that in a talk title, it's increases its acceptance chance by 3 times. But besides that, I think it's also important in a modern world, because if we are looking at their modern applications, very rarely they would be designed where our storage is really not distributed some form, right? You have just like one little object which holds all our data with no distribution happens. Why is that important? Well, of course, from redundancy, performance, and scale, we are looking to look at some sort of a distributed system. I think that especially becomes in the cloud, right? Where in cloud, we are much more learn not to rely on a single instance, right? You're not going to have, oh, this is my very, very special server. It didn't go down ever in the last 3 years, and I will just take a very good care of it, right? That's not a modern approach used in the cloud, right? Instead, we are prepared to build our systems where any single node or system components can disappear with no trace, right? And hence we need that kind of distribution happen either at with our own means or with the means by cloud providers. Now, let me cover quickly their cloud, and that's kind of going back to my keynote today. There are different ways to look at the cloud, right, and choose how you're going to utilize with the cloud. You can think about the cloud as comparing it to their utility computing, right, and really see that as something which is commodity you use as a building block, or maybe you can see that as a proprietary platform, as we have existed and have kind of ebbs and flows through many last decades. I think it is interesting what if you are looking at the major cloud vendors, their view, of course, is to really use that as a proprietary platform. If you are learning to be the certified architect in a big cloud, you are taught to use DynamoDBs and Amazon Auroras and so on and so forth, instead of saying, hey, you know what, just use commodity stuff and use the open source for the rest of stuff. Well, obviously, because you don't make as much money if you sell the commodity services, right? Or if that's what people utilize. At the same time, I think for the users at large in the open source community, it makes sense to embrace and invest in building feasible open source alternatives so we can get the robustness, performance, usability of technologies we need based on their commodity cloud. And that is what we are doing at Percona, focused on a specific area of their open source database. But now, while I see the using open source as a best way to achieve your needs, especially long-term, both from commercial standpoint as something which is much more fun, I am going to cover in this presentation different ways of doing things. And I think you can group the choices in 3 different groups, right? One is there are going to be proprietary solutions which come from the cloud vendor. The other is also proprietary solutions, but which cover from a third-party vendor and often available among different cloud vendors. And finally, there are open source solutions. Now, one thing I also to warn you here is what while many clouds like to talk about comparability, saying, hey, our technology is open source compatible, typically that is what I would call Hotel California compatibility, meaning that is very easy for you to move from the open source technology to the open source compatible, so-called technology in the cloud. But usually it is hard for you to move back because, well, guess it, right? There are going to be some additional features in that open source implementation in the cloud. Cloud folks will highly encourage you to use them. And then when you do, you are locked in. Now, speaking about the open source, we have a huge variety of both open source and kind of open source licenses, right? And there are a number of software vendors which will be more properly called, let's say, open core. We'll call them, or some other words, right, would call themselves open source. So I wanted to highlight what I think is important for you when you are choosing the project and a vendor in an open source scenario, right, from a practical standpoint, beyond the license term and so on and so forth. The first one with open source is free as in beer. And what that means for me is what I can go ahead and deploy that solution without incurring additional software costs where I need to be. Right? It's probably going to be in the cloud, on a prem, on my own laptop, right? That is one criteria. The second is, do I have a choice of vendors to get help from? I think that is very important because if there is monopoly, there is a greed, and then there is a mediocrity and incompetence from vendor side, right? And if you have multiple vendors, then they kind of keep each other honest. And I think that is a very important value from an open source software, to be able to get help from multiple vendors if you choose not to do it alone. And a third one with openness, I think is important. What if you choose so, you can make that open source software better, right? Within open source, often it is not as polished, not as featureful as a proprietary software in the same field. But at the same time, you can make it better or hire somebody to make it better for your specific use case. And that is how it is different from proprietary software. For me, these are very important criteria for you to consider. You may not put the same weight on all of them, but that is what I would make sure to consider anyway. So in our case, when you look at the cloud technologies, I will focus on the top 3 large cloud vendors in the Western world: AWS, obviously, Google Cloud, and Azure. In terms of open source approach, I will mostly look at the Kubernetes ecosystem, because if you think about the cloud native approach, right, when you are really building things designed for a cloud and utilizing cloud concepts rather than simply, let's say, retrofitting your legacy applications of sort, right, and just saying, well, I will provision VMs in the cloud instead of physical servers, then Kubernetes is their dominating force, in my opinion. Okay, with that, let me look at some storage types and options. The first, I would talk about the commodity service. When I mean the storage is a commodity, that means while there may be subtle differences between the different clouds and implementation, moving between them relatively easy because interface is kind of easy. For example, your node local storage, right? Basically, your disk, it exists in pretty much all the clouds out there, well, almost or most of them. And it is very simple, right? Performance properties may be different between different clouds, but the interface makes it easy to move between. And then it actually can be quite decent for temporary storage, processing, right? And even as a built-in block of your own distributed system, because often it can be relatively cheap compared to the other options. The next one is network block storage. In AWS, it's EBS, Elastic Block Storage. It's known by different names and different technologies, but again, it is a relatively simple interface. You essentially mount that as a block device. And again, performance properties between them may be different between cloud vendors, but the functionality is at large the same. Now, in additional, there are some additional vendors which provide functionality here. The NetApp and the Portworx, I think, are the most important to name here. Typically, they both provide solutions for private cloud as well as in a public clouds, and they allow you, if you use their interface instead of clouds, kind of abstract your application from either differences in APIs which exist in those cloud vendors. There is a lot of solution, so in this case, in the open source as well, right? Now, because I think a block storage is a relatively commodity block, which is relatively inexpensively available in many clouds. Often people do not try to build their own, at least in the public clouds. But if you need for private cloud, there is a number of solutions available with which you can get something similar to the EBS in your own environment. The next one would be file store, right? There, the block device gives you network-based block device, which gives you their network-based but as a file system. That typically comes with either NFS or SMB interface, right? Or maybe both. And again, those are available from all the large cloud vendors, and the same NetApp and Portworx vendors, they provide you the file system access as well. We also have many similar projects provide the open source file system access to what they have provided as their block devices. The next one from a commodity storage will be what you call their object store, right? S3 on Amazon, Blob storage, Google storage in GCP. And again, that is very commoditized solution, right? Besides the same NetApp and Portworx, which provide you ability to do that in your own data center, there are a lot of other clouds which have those interfaces, such as Wasabi, Blackblaze, DigitalOcean, Linode, now even Cloudflare recently released the S3 compatible API, right? So that is really becomes a very heavily commoditized service and really very low-cost service, which is pretty cool. There is also a solution in how you can roll out and S3 compatible storage in the cloud, in your own data center, right, or even your own laptop. In this space, I think Minio is a project which is really dominating in space, right? If you think about, hey, S3 compatible, Minio is probably the final answer. But I think the good news is that that is not the only project, and Ceph and Rook, which I already mentioned before, we also have a ability to provide S3 interface. So that is where it comes to the commodity storage. And again, I like this storage as a building block for application, because even if I'm relying on something like an Amazon S3, their lift to move that application to a different object store is likely not to be so hard, especially if I am smart enough to use some libraries which may have a support for different object stores, right, which are plenty as well. Now let's talk about databases and data stores. The thing of those is they typically have a pretty complicated APIs, languages, right, and a lot of behavior differences. So moving between them is hard. Even if you think about something which is kind of essentially the same class, like, well, we talk about operational relational database, which speaks SQL as a language, right? Then moving from something like Oracle to Postgres is not easy, right? It's often would be multi-year and multi-million-dollar project to do that. So in this case, even if offerings look similar on paper, right, and kind of maybe have all similar checks, lift will be significant. And with that, I think that is very, very important to make sure from the day one you are using open source technology if you want to avoid vendor locking. Okay, so let's first start with queue streams and data pipes, which is not really your classical database, but that is important data plumbing, which moves the data around in the system. And that is actually a very important component of many modern data architectures, right? Because it is a very large group, actually there is a lot of solutions which exist for between their different cloud vendors. And I think especially you can see the list is large for AWS, because in many of their systems for queuing and PubSub and so they have been created before some of the open source solutions such as Kafka became popular. If you look at the proprietary solutions, then you can see a lot of Kafka-based stuff, right? Because that is, I think, where a lot of other vendors, not the cloud vendors, have been really coalesced about the Kafka as a standard. That's not the only one, but I think that is the biggest one, right? If you look at the open source, that is, again, when you have a large amount of solutions, Apache Kafka, Pulsar, but there are also RabbitMQ, ActiveMQ, kind of for queuing coming from, I don't know, what's the previous generation. And I think this area is also rather fragmented and open source as well. There are certain technologies which Go people like or Java people like, and so on and so forth, right? Some of them are very much integrated with that development platform what you use. For relational transactional databases, again, all the clouds offer a lot of things here, and for a good reason, because all the databases are very different. And if people are looking for MySQL and they want to move their MySQL workload to the cloud, you cannot just tell them, hey, we got Postgres. Well, it's also SQL and relational database. Well, not so fast. Moving from MySQL to Postgres or vice versa is, while possible, it is not easy. In AWS, they have a large selection of open source databases. We have obviously Aurora for MySQL and MariaDB. There is and MySQL and Postgres. There is RDS, right, which has MySQL, Postgres, MariaDB, Oracle, SQL Server, right? You can see a mix of proprietary and open source databases. And Azure and GCP also have quite a mix. So their approaches can be slightly different in this regard, right? For example, we can see in Azure, they have invested a lot in sort of like a hyperscale, right, which we can mix with Postgres, right, to give you sort of sharded PostgreSQL installation, right, which previously was known as a Citus data because before we bought it. With Google approach, we also do not have Aurora replacement, but they have recently released their PostgreSQL interface for Google Spanner. So their approach is, hey, if you want that kind of massively scalable database to replace your Postgres, Well, here is what you get. Obviously, if you look at the proprietary solutions in the cloud, that is where we have a lot, right? Pretty much every vendor in a database space right now, they take their technology and make that available in the cloud, right? That is a pretty much table stakes out there. And then there are also a number of vendors such as Instacluster and Aven, which say, hey, you know what, we can have this proprietary interface, right, which allows you to deploy those open source databases in variety of the clouds. And obviously, when you look at the open source, there is some good amount of databases which exist, right, in a relational database space. I want to particularly flag a couple of names you may not heard about. This is a Yugabyte and TiDB, right? These are both relational databases which are really designed to be massively distributed from the ground up. Yugabyte, it speaks PostgreSQL protocol, right? And TiDB is has a MySQL protocol compatibility. TiDB is done by PingCap, and this is a Chinese-based company, right? And I think with that, even though we have a lot of good technology and it is also rather popular in China, for political reasons, they're not quite as well known and adopted in US market. Okay, analytical databases. If you look at the analytical databases in the cloud, again, there is a bunch of solutions which exist among the cloud vendor, and I do not claim even what this list is completely full. Here is what we look at their relational database from analytical standpoint from a proprietary space, right? You can see a lot of technologies here. I specifically want to mention the last one, which is interesting, right? Oracle HeatWave. That is a really extension of a MySQL, which is only available if you run MySQL in Oracle's cloud, right? So Oracle is taking its kind of its own way, right? Similar to the Amazon Aurora path, saying, hey, if you want better MySQL, we'll make it only available in the cloud, and there are some, bells and whistles which exist out there. There is a lot of solutions which exist for analytics in the open source standpoint, and they are, in this case, quite different, right? There is a lot of different things how you can approach analytics, right? So I think there's a more variety in this case among what kind of functionality they offer. I want to specifically mention here TiDB, right? They, I think, is built very interesting technology, right? There it's distributed technology which stores the data sort of in both column store and row store format at the same time, and they are focused on what's called HTAP, hybrid transactional analytical approach. Document store, right? In this case, not a surprise. Again, every cloud has their own approach. In many cases, I would say even more than one of them. AWS has a document DB with MongoDB compatibility. Azure also have a Cosmos DB, which has both kind of native API and MongoDB compatibility, and GCP comes with a Firestore. If you look at the proprietary, we'll have in this case, of course, a combination of, again, a database as a service solution such as MongoDB Atlas, as well as enterprise versions of open source software, which top open source / source available, whatever, vendors such as MongoDB and Couchbase offer. If you look at the document store, right, I would mix here both the open source and source available together for simplicity. MongoDB, as some of you may know, have changed the license from open source to source available a few years ago, with especially kind of restricting their competition in the cloud. So MongoDB, Couchbase have solutions. We at Percona provide Percona server for MongoDB, right, as a sort of extended community version of MongoDB. And also relational databases can be an interesting alternative, because after the document store and JSON become popular, I think it's now over the last decade, all open source, all relational databases, open source and proprietary, invested a lot in making JSON support quite good. Now, actually, if you're interested in how that works, you can check out Percona blog. We have one of our guys actually wrote a series of articles about how we use JSON in MySQL and PostgreSQL and in MongoDB, right? Kind of with a similar application, right? So you can compare look and feel. Now, key value store. With key value store, I think there are two very different use cases we're often looking at. As a primary data store, kind of like a high performance but very simple interface, and as cache. In many cases, you see key value stores used together with relational or other kind of databases as a cache. Right now, I think Redis is a very popular key value store, which is interesting enough. This Redis interface can be seen as a different names in the cloud, right? AWS Elasticache is typically used as a Redis interface, right? GCP calls memstore, all the Redis interfaces. From a proprietary standpoint, I would mention Redis. Again, they have both enterprise version and a cloud deployment. And when you go to open source, I don't want to tell you just Redis again, even though that is, I think, is the most popular key value store database those days. There are other solutions, like some people still use Memcache, right, which has been very successful, robust for simple workloads, as well as there are solutions like KeyDB, which are kind of newer, up and coming. And there are many other solutions, right, you may look as well. If you look at the persistent key value storage in the cloud, there are the same solutions. So in Google, you can also use Bigtable. Now, I should say I'm kind of fudging thing a little bit here, right? Some of you may say, "Oh, Peter, Bigtable is not exactly key value interface." Well, yes, it is, but it's kind of more simple compared to a full-blown document database or relational database out there. I think here you also can look either Redis Cloud or some enterprise versions of open source solutions, which do have support for persistence in a key value data store. If you look at the open source solution, again, there is quite a few options here, right, ranging from Redis, Cassandra, ScyllaDB, Aerospike, a lot of them say, hey, you know what, yes, if you're looking for a simple key value store, right, a key value store plus model, we can really support you here. Okay, time series databases. That is another special purpose case which I want to cover, which really has been getting a lot of attention recently, both because of the Internet of Things environment and all our obsession of like a monitoring observability. We get a lot of time series data, and which is much better stored in a purpose-built time series database, right? And there are cloud vendors, obviously, which you can use for storing that time series data. In terms of proprietary space, you again can see pretty much everybody I will mention an open source space. They often would have some proprietary or enterprise version, which will fall in this case. So here are the open source and related technologies. And you can see quite a lot of them here. Let me mention a couple of which I think is particularly interesting. Timescale DB, I think, is a very interesting technology because they are building on Postgres, right? So you're saying, hey, I love Postgres, I love SQL interface, but I would like more robust and high performance time series support. Then that is time series is a great solution for you. Another area is Prometheus. Prometheus, especially, I think, because it's kind of tight, Kubernetes integration has been very interesting and popular as ecosystem. But the fact Prometheus itself is kind of relatively limited, right? And you can almost think about that as a sort of like a proof of concept implementation. What I mean by that is kind of doesn't have built-in availability. It lives in a single node, all right, rather than being distributed. And with that, you have a number of solutions which are Prometheus compatible, right, or maybe kind of extend Prometheus even in some cases, which came to market, right? So M3 came out from Uber, right, and also available from like Chronosphere, right? I think they recently raised like 200 million, right? So they're doing a lot of development on that. Would be example. Cortex, that's another Prometheus comparable implementation, right? But which is designed for larger scale systems. And Victoria Metrics, that's another one which I should mention. We use that in our Percona monitoring management solution because it's sort of more efficient than Prometheus, and it's also something which has an open source version, can be run as a cluster version, right? Unlike Influx DB, for example. And it's also one of those databases which kind of really talks multiple protocols. So with Victoria Metrics, while a lot of people like ourselves use it in a Prometheus compatibility, you can also have it to talk Graphite protocol, right? Or inject data from Chronograph, right? And then FluxDB, time series, and Victoria Metrics. So quite cool. Okay, in the last few minutes, I also wanted to talk about how we see Percona role in all of this. Now, I see us at Percona as doing a lot of work really at pushing boundaries of open source databases while really sticking to what is open source. And in this case, I will be honest, what we can be successful at large extent because we are standing on the shoulders of the giants. We are not just saying, hey, we are going to build completely greenfield technology from scratch. We are looking what best, most popular exists in the ecosystem, right? And take the open source or source available version and make that really enterprise grade from security, availability, and so on and so forth, while releasing changes back again as an open source, right? That is, you can think about our model. And all of our software is free and open source. We don't have any like open core or enterprise versions of our software, where we provide distributions, which is how you run Percona database software on Linux, as well as we have operators for MySQL, MongoDB, and Postgres, and that is how you deploy technology in a Kubernetes. And I think in Kubernetes specifically, we have some of the most featureful and robust operators out there, especially for MySQL and MongoDB. With PostgreSQL, we just released Operator as GA a month ago, right? So it would be probably, you know, too arrogant for me to say it's the most stable out there. But for the other stuff, it's been around for a while now and used by some very massive companies. And the other thing what we do is Percona monitoring and management, which is your single pane of glass for your open source databases, right, which has a lot of monitoring features, and we are building now a lot of features for management, you know, such as, you know, backups, for example, as well as database as a service experience where you can use PMM to essentially provision database cluster, right, with using Kubernetes as a backend, being that versus, you know, your Kubernetes, right, to maybe manage Kubernetes in the cloud. So with that, as a summary, you can see what if you think about the storage from the bird's eye view, there are really a lot of options out there, right? In this case, and what we see often, it's the choice may not be easy, especially when you go to a database space. I think we all know, like, well, for this stuff, we wanted to store on local file system, and this stuff goes to S3. But what particular database is good for what data need? That is where a lot of complexity happens, because there is lots of choices, kind of lots of marketing, lots of stuff you can find in the internet, right? Of various quality. But what is a good thing is, if all that stuff which is available in a proprietary space, there is options from the open source coming up for pretty much every class of a problem. And many of those are already very mature, and all of them pretty much are getting better every month, every year. With that, that's all I had to say. And if you have questions, I'll be happy to answer those. Yes. So, Postgres distribution, do you support plugins like that? Well, so for us, yes, you can use plugins, right? So it's 100% binary compatibility with what open source Postgres provide. We as a Percona wouldn't offer support, right, for plugins, right, which is outside of a set of plugins what we support, but you're welcome to use. You're welcome. Oh, well, for us at Percona, that is simple, right? Because everything we do goes open source, right? We don't have a proprietary solution, right? In general, right, if you talk to people who are in the enterprise space, right, and as I CEO kind of have to learn that a lot, right? Typically, you say, hey, you know, what you want is to have features that open source, which can drive your adoption as much as possible. You don't want to stop adoption, right? But then it talks about, hey, what is it people who sign the checks versus developers care? That is what you want to make paid. So features which empower, for example, let's say compliance, or often it goes kind of in security, right? You will find that is often being commercial. Okay, yeah, well, go ahead. Well, yeah, I mean, I would say I didn't talk about the search, but I could, right? Yes, I mean, that is an important class of a data store, right, for search applications in particular. Yeah, so that is a type of. Any other questions, folks? Oh, look at that! Did you notice this guy came here? This is Barrett, and he's amazing. And you know why he's amazing? Because he has some stuff for you, right, Barrett? Yeah. Okay, yeah. So he has what do you have? Exclusive swag. Talk exclusive swag. Isn't that wonderful? Okay. Yeah. Any other questions, folks? You see, Bert? No questions. We cannot wait to get the talk exclusive swag from you. Okay. Thank you.